All right. Good afternoon from Nigeria. Thank you, Joel, and thank you so much, Kau, for setting the pace also with ontology. So mine is just to reconcretize some of the ideas, particularly for some of our members that are joining, and also for the senior data stewards to see to what they have been working on, particularly as it regards to their assignments and other things. So here I'll start from just the workflow. But if I really want to describe, for some of us that have started long time around here, we use the allelograph to play around the data analytics, just to help in visualization, and also to see how the relationships between the data, and also to qualify the ontology as described by Kau. So sometimes we look at it that why the workflow. The first point here is just to underline the interoperability that exists within the FAIR concepts, and just to link up with some of the knowledge of computing that many of our senior data stewards and the friends of IT are familiar with. We have the relational database that is a representation of the structured and unstructured data, and also creating the relationships as one record relates to the other. You remember the example Kyle was giving about the gender and also the sex. So when you define some records, then there needs to be some relationship so that you can call and also have a relational intersection between the records. Then I will move fast into talking little about the CEDA. So just as Kyle was saying, the OWL, which is the ontology language, is a deeper representation of what we have been doing. So earlier, we used the concept of CEDA to define what the data and the attributes properties can be as we move into hanging our data across some of the solutions. So I will just take us through some of the applications or some of the concepts of fair data and what we can also use. So we have the right field, which is also used to create metadata, and very simple to use as it accepts data that are mostly created in Excel. And if you find it a bit difficult to see how you can structure your data, you can use some of these applications to support the interoperability. So I'll be showing some part of them, even though on a very fast route, to see what I was able to do. Earlier in our study, we started with RedCap along the data production. There was a time we were also using Kobo Collect. So now we are trying to look at other options, particularly like the Open Refine and other concepts. So let me just give a small view of so this is a typical Excel file that I just pull to see what it can give me in a structured form. So I picked this record. These are just dummy records of students in my school, not related to anything about health, but just to share the relationship and the flexibility that exists in this great application called Open Refine. And it has so many functions, from how you can export them into the SQL, Excel, create some ODF spreadsheets, and also take you back to Excel if you want. So from this kind of concepts, you will notice that we can play around having even the option codes, just like I was showing earlier, even though his was on the red GitHub. So here we can also adjust. We can select what we want. We can give them the ISOs, that's the standard, and we can as well download them in different formats that we want. So let's go back into the slide so that we see other metadata creation tools. So it is very simple because the document is straightforward. What I did was to visit the site and download them and try to open an existing Excel file to create a template for myself and also to see how I can load the ontologies around them and see the categorization of the data I already have in Excel. So take, for instance, all of those data we are creating from our health facilities, we can as well get them in a global usable format, which also qualifies the FAIR concept. Then we, after the right field, we moved into the Prodigy. I think also Kau spoke about it in our one of our presentation, and we were able to play around that also just to hit on what we have. So let me see if I can also show a small part of it. I don't know if we have done that earlier in some of the presentations. So what it looks like, let me see if I can share. So it helps you to also talk about the classes of data. You look into the properties, and after installation, you can as well play around them. So here we have the IRI, which is the Internationalization Resource Identifier, similar to the unique identifier that is used in the ontology. So it helps you to also create classes. Very simple approach as we have here. Then you define the relationships. So just to add to this, if we are familiar with the concept of PostScript, PostScript is also a metadata or an encoding format that can be used to centrally and also globally create a document that can be reused without altering so much of what we have. Sometimes if the values not satisfied, it can prompt some error to now clean that up. And this is another one that we have. Then a solution that unstructured data into a more crucial format that is easy for reconciliation. So it also helps to allow external databases have accuracy and makes it easier for customization. So OpenRefine also helps to do what we call the data transformation, such that it can be used adequately. And it offers different formats for export, such as the CSV, that's the comma separated values, the Excel, the JSON, the XML, and the RDFs. It also supports the ontology mapping, as I just mentioned, to give you better graph patterns. And most importantly, it is used in the FAIR concept of findable, accessible, interoperable, and reusable form of data. So some of the key terms that it helps to do is the clustering of data. It also helps in integration. So let me see if I open Refine. I think, okay, now let me share the, okay, I'm trying to also do a live pulling of the right field that I explained earlier. It comes like an Excel file. Then you have the sections for the ontology hierarchy. So it gives you all of the value. Then you start adding the properties accordingly to every part of the records. Then we have this also. that can be used to specify and also create either from what you already have as a URL. Okay, let me see. Then you can use some that already exist, then you can work with some. So this is just from the library that I want to play with. I don't seem to have, okay, yeah. So just like I was showing earlier, so it gives you the URL. Here we have the IRL, we have the version, we have the lexemes, you have the class counts and other properties. And here we have few entries, right? So basically this the things that this. So this what we have. Then moving into the allegrograph, that's to show the different relationships and relationships that we have, particularly when we use the query of the Sparkle to show the data production that we've been doing for quite some time in our study. Uh,
I think Dr. Ibrahim's connectivity is not playing along.
I can say something, Joe, as we are waiting for Dr. Ibrahim.
Thank you. Yeah, that'd be good.
Yeah. So what I wanted to say is that the presentation of Dr. Ibrahim shows us a number of things. Number one, that there are different components supporting the different tasks of the whole verification process, which is what from session 1 to session 7 we have been going through. And it is important to understand the different components that are part of the verification process so that then you can determine the workflow that is best fitting a particular objective. So, for instance, if you have already a structure for the data because you have used COBOL or REDCap to have the entry of the data already structured and maybe in REDCap linked to ontologies, then it will be a more or less straightforward transformation into the allegrograph where now this data, this metadata, can be stored safely and prepared for data visiting. So that is what we call verification by design or de novo verification. It means that right from the creation of an instance, a data instance, it is already structured and linkable to controlled vocabularies. So if you can bring structure in your data, that may be a preferred workflow because in that workflow, the provenance is already annotated right from the creation of that digital instance. But there are also examples, and in the teams that we have, of data that is structured but not annotated with metadata. For instance, research data in an Excel sheet. Then OpenRefine is a very excellent tool that allows you to annotate this data with the controlled vocabularies and prepare it for transformation in RDF and uploading it in Allegrograph. So in that team, a team where the objective is to work with existing data, then that workflow would be the best workflow. There's also the possibility that you are working in a relational database form, like for instance with ANC data captured in, let's say, Afyake, if it was Maxwell. And then again, we could use something like OpenRefine to insert, or like right field to insert the component that will lead to verification, because the controlled vocabularies allow us to make the triples that can be uploaded as metadata in the Allegro graph without disturbing the relational database structure. So the point of the session 7 is, number one, to be clear that there is every freedom to make the ontologies fit to the objective and the understanding of relations that you have. That is really what Kao has been saying. And he has been explaining that there are different tools of doing that, but that at the end, they all do the same thing. And that is that they create relations between digital instances based on a reasoning. But we are the authors of that reasoning. And if they already exist, we can use existing ontologies and create our vocabularies around it. And if they don't exist, then, or if we need to adapt it because our understanding is different, then we can create the we can create those ontologies. And that is very, very important, because we don't want to be straight jacketed in our understanding. We need to make sure that the understanding of the instances that we are creating with the data that is becoming available, that they are fit for purpose in the way we want this data to be understood, right? Because otherwise we are self-creating, self-perpetuating things that maybe we don't even believe in. So that is very, very important around the idea that, yes, add existing standardized ontologies into your common data model, but if it doesn't fit the reasoning that is right for your research, then make sure that you create your own and that you make it persistent, for digital annotations, so that it remains to be valid over time. And then the presentation of Dr. Ibrahim shows us that with this tool of the common data model that we have shaped, that there are different ways in which we can then add these ontologies, so that the outcome of it is a structured way of transforming data through the available tools that are there. So I think Dr. Ibrahim is trying to take back the floor. Is that right?
Okay, yeah, sorry, Prof, the network is a bit bad, but just to rush up and close up what I was trying to do earlier. So just like Prof said, if the data are not in the let's say the global format, which is the FAIR concept, it is almost unusable to other people that are not within the creation team. Such that example here, just to play around what I was trying to do for the demo, if the network will permit me, we have a preview. I'll just run through the previews. So now this is one way that you can have your data represented. And in another format, if you want to just check, it gives you another representation and that is similar to maybe what you need to work with. And another one. So you can now see the flexibility and the interesting parts of the Open Refine. So here I just try to look at what the exportable response of the huge data I picked from the Excel will look like. So we have different formats, and interestingly, I see that. Let me just share. Let me share this. So I think the material will also be shared on the group, and you have easy way to also play around the data types. If you recall, for many of us that were part of the design of the CEDA localization, we had all of these attributes that help us to redefine data types. Here we have the text, number, Boolean, and date, and so on and so forth. So once you just change and apply, you can now apply and now start playing around. Now you can see that it gives me false because it's throwing me off to say this is not a valid kind of data entry. So this is mostly done in the parts that you need to apply in the design, or for the senior data stewards, as we move in, you will understand more of what we're saying in sharing lots of these options of the FAIR tools and also the ontology manipulation tools that we have for verification of data. Thank you.
Thank you.